All right, so we're 1.1b, making predictions with linear models, day 1. Okay, so you should have gotten a little quarter sheet, and we need to talk about slope. Do we remember slope? Okay, so following along up here, we have our slope equation. So our slope equation is graphically, you're looking at rise over run, right? So how much did you go up to get to the point? How much did you go over to get to the point? Okay. Mathematically, what you're doing, this is your slope formula. It's your y1 minus y2 over x1 minus x2. Do you remember that? Okay. You have 3 types of slope. You have a positive slope. Your positive slope line rises from left to right. It's just like we read books from left to right, we read a graph from left to right. Okay. You have a slope of 0. Slope is horizontal. Okay. Think about it on a treadmill. It's at 0, right? No incline. And then we have undefined slope, which is the vertical line. It's your treadmill's put up, right? You can't use it right now, right? You're not working out. It's undefined. No workout happening. Okay, unless you're Spider-Man. Unless you're Spider-Man. And then negative slope from left to right, the line falls. Okay, so do we all remember our slopes? Sounds familiar? Okay, we're going to be using our slope formula today and using rise over run. Got it? Other thing we need to remember is X and Y intercept. Okay, so on page 5, where you're putting this quarter sheet, you're going to also make sure you write down the definition of X and Y intercept. So the X and Y intercepts are the points where the straight line crosses the X and Y axis. Okay. Yes, on page 5. So on page 5, you're going to put your quarter sheet. No, just you can title it as slope and intercepts. You're like on this. I did that part for you already. You just have to write what's in the yellow box for intercepts. Cool? Yep. All right, I'll give you a moment to do that. Okay. All right. So when we look at this graph here, you can see that the y-intercept is at 2. So the coordinates are 0, 2. When you look at this graph, the x-intercept is at -1. So we write it as -1, 0. Okay. Remember, your y-intercept means x equals 0. Your x-intercept means y equals 0. Yeah. Okay. All right. Let's keep it going. Okay. So now we're going to go to page 6. On page 6, we're going to talk about our slope-intercept form, which is y equals mx plus b. Well, not page 6. You should have room. Sorry. I wrote page 6. I didn't mean to write page 6. We're still on page 5. Sorry. I'll fix that. On page 5, you still should have room to write your slope-intercept and your point-slope form, correct? Okay. All right. So slope-intercept, we have y equals mx plus b. By show of hands, how many people remember y equals mx plus b? Yay! I should see all hands. There we go. All right. So when we're given the slope m and y-intercept b, cool. All right. Next thing we should remember, least used but point slope form. Does it look familiar? We've seen it before. Okay. Y minus y1. Y minus y1 equals m times x minus x1. Okay. And when do we use this? When given the slope m and a point x minus x1. Okay. And we can simplify and solve for y to change the form. I'm going to go ahead and mute again. All right, so let's dive on in. So we're gonna watch this quick little video. Don't worry. And it's not on speed. It's not fast forward. All right, so believe it or not, a few years ago, it became a really big thing to stack cups, right? A big competition and everything. It was like almost a decade ago. It's crazy to say that, but it was a really big thing. And so I was like, well, you know what? Let's bring back cup stacking. Well, we're not going to actually stack cups. We're going to talk about someone who works in a convenience store who stacks cups, and it's a little different. But I just wanted to like kind of show y'all, get you interested in stacking cups. So what we're going to be doing on page 6 is we're going to talk about she works in a convenience store. Actual page 6. Like we're on actual page 6. because we got to draw a graph on the table, okay? Or an actual place. Xing works in a convenience store and has to record the inventory of coffee cups that are currently in stock. The store shelves hold many tall stacks of cups. So she wants to find a more efficient way to determine the number of cups in the store than counting each cup in every stack. She wonders if she can find a formula to determine the number of cups in a stack from the height of the stack. Is her method possible? Explain how you know. All right. Anyone? Hudson, how would she figure out?
All the cups are the same size, so they're all the same. If the stacks are all at the same height, then they all have the same cups.
There we go. Since the cups are equal size, right? Their height should be the same, and which means that the same number of cups should be in each stack, right? So that's proof in itself that we have some type of function happening, correct? All right, so we're gonna go forth with her speculation. So what we're gonna do is we're gonna, she measured 1 cup, and when she measured 1 cup, it was 6.8 centimeters. Okay, not centimeters, inches. So in a very tiny cup, right? It was 6.8 centimeters, 6.8 inches of a cup. Then she measured with 2 cups stacked, and it was 7.4 inches together. Okay, so what we're gonna do is we're gonna create a table. Then we're gonna create a sketch of our graph. Your graph doesn't have to be perfect. It doesn't have to be on graph paper, but if you do want graph paper, I do have tiny graph paper that I can give you. Okay. And we're going to find the slope and then use point slope form to find the equation. Cool? All right, so here we go. So quickly make a table, and I will be around with the little tiny graph paper if you want little tiny graph paper, or if you're okay with just drawing straight in your notebook. All right, so let's talk about this. So we create our table. So our table is first to determine, what did you decide was your X variable? The number of cups is our X variable. So we have 1 cup and 2 cups. So our dependent, our Y variable, is going to be their height. So 6.8 inches, 7.4. And I don't know why I did not put my inches in there. Apologies. Okay. All right, now, when we're graphing this, do we have to worry about negatives? No, because you can't have a negative height of cups. Does that make sense? So therefore, we're only focused in quadrant in the matrix. I've never seen the matrix. Oh my gosh, don't say that. You just wanted to say something to make Miss Jones feel old. Cool, Hudson. Cool. All right, so we have our graph, and we're gonna we have 1. And so notice here that this isn't perfect. So it's 6 8/10. So I'm gonna go up 1, 2, 3, 4, 5, 6, and I'm gonna estimate my 8/10. Okay, I'm gonna go to 2, and I'm going to 7/4. Again, it's gonna be an estimation, a little bit below half. Okay, as I'm looking at this, does it seem like they could be linearly connected? Yes. Linearly, like I can draw a line.
I think it said literally.
Linearly connected, sorry. Okay, so that lets you know there's a line. So now that I have my table representation, I have my graphical representation, I'm now going to find my equation representation, right? So to do that, step one, we have to find our slope. So one, we have to find slope. Okay, since this is in a situation where I can easily count rise over run, we have to use the slope formula, right? And the slope formula is, that's the equation of a line. Slope formula is y1 rise over run, which is y1 minus y2 over x1 minus x2. Okay, your x and y's are coming from your what you have. So this one is my x1, this is my x2, this is my y1, this is my y2. So now I'm going to find the slope. So finding the slope of this information. So m equals, and we have 6 8/10 minus 7 4/10 divided by 1 minus 2. Okay. If you owe me $7.40 and you give me $6.80, how much do you still owe me? So 6 minus 7.4. 6.8 minus 7.4. Oh, sorry. 6.8 minus 7.4. Negative 0.6. And 1 minus 2 is negative 1. A negative divided by a negative makes a positive. So we now know our slope is 6/10. Okay. It's either can be written as 6.6. I can write it as 6/10, which equals 3/5. Agree? So the decimal and the reduced fraction are both acceptable slopes. All right. So now we're going to find our equation. So to find our equation, notice how we have a point and a slope, right? We actually have 2 points that we can choose. So we can use our points and we can use our slope to help us find it. So we're going to use point slope. Remember, point slope is your y minus y1 equals m times x minus x1. So I'm going to substitute everything I know. I know that y1 is 6.8. I know that my slope now is 0.6. And I know that my x1 is 1. Okay, I want you to take a moment to simplify and get y by itself. Okay, so you're going to simplify and get y by itself. So when it says to simplify, that means we gotta distribute, right? Did you distribute your 6/10?
Oh, yeah, yeah.
So we get 1 minus 6.8 equals 0.6x minus 0.6. And then after you distribute, what did you do? And we add 6.8 to both sides. And so that leaves us with, perfect, y equals 0.6x plus 6. You're subtracting. You have a negative 0.6. It's a negative 6. So it's negative 6 plus 6.8, which gives you 6.2. So this is our equation of our line. So we got y equals 0.6x plus 6.2. All right, how do we feel? Do y'all kind of remember doing this a little bit in your past lives? Okay, perfect. Okay, so what we're gonna do is you have to make sure you get this, I want you to take a moment and turn to your table mate or talk to somebody. Turn to your table mate, your elbow partner, and in your own words, explain to them the process of finding a linear equation given the slope and a point. Okay, so explaining what we just did. All right, so what we're gonna do is for the remainder of class, you have an assignment on Canvas. This is our first assignment. It's 1.1b assignment on Canvas. You're gonna use your notes and previous knowledge to complete. You are encouraged to do it, to work with each other, peer check while you're working. You're to show your work on page 7. So page 7 is where you're gonna show your work for our activity. Okay. What you don't complete is due for homework. Okay.
And when is that?
It's usually due, I usually give you 2 days for homework.
Oh, yeah.
Okay.
Not like one of those going people who give it like midnight.
It's due midnight, like the next day.
Yeah, like midnight on the same day. Like,
No, it's due like tomorrow at 11:59 p.m. Does that make sense?
Cause that gives me like a full day.
Yeah, no, it's due tomorrow at 11:59 p.m. All right. Any questions about what we're going to be working on for the remainder of the period? All right, let's get to it.